Good morning, happy Friday, happy the last class meeting that we'll have. So let's go ahead and get started here. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. So today we're going to go through a chapter 5 test in preparation for the final exam. I will be back this afternoon at 1:15 with an office hour. However, this is the last official class meeting. Monday, you are to take your final exam. It needs to be finished by 11:59 p.m. Monday night. There will be no class meetings Monday, no office hours Monday. As far as your grade, don't email me asking me for your grade. I will email each person their grade once I have graded their tests and calculated the grade for the course. Okay. Anyway, it's been a pleasure, and here we go. Let's see here. All righty. So this is, okay, come on. This is chapter 5, problem number 1, chapter 5 test. It says, find the degree of the polynomial. We have 8x cubed y plus 2x to the 5th y cubed minus 7xy to the 5th minus 6y. First of all, I want to remind you that there is an implied exponent of a 1 here and here and here. Okay. So the degree of each term is the sum of all the exponents on all the variables. So the first term would be degree 4. The second term would be degree 8. The third term would be degree 6. And the fourth term would be degree 1. However, they want the degree of the entire polynomial. To get that, we take the degree of the highest powered term. And that is going to be our answer. So find the degree of the polynomial. It's going to be 8. Okay. Problem number 2. Subtract the polynomials. We have the quantity 5a squared minus 4a plus 5 minus the quantity a squared minus 5a plus 9. When there's nothing in front of a grouping symbol, it's as if though there's a 1 in front, and distributing that, we would basically get what's inside, but at the same time get rid of the grouping symbols. If there's a subtraction sign, that's like distributing a -1 or a -1. So we get minus 1a squared. Minus times minus is plus a to the 5th, and minus times plus is minus. Now that we've gotten rid of the grouping symbols, we can combine like terms. 5a squared minus 1a squared is 4a squared. Minus 4a plus 5a is plus 1a, and plus 5 minus 9 is minus 4. Just a reminder, if you put a 1 in front of the a, even though it's implied, WebAssign marks it wrong. So be careful with that. Okay, so we've got 4a squared, and then plus a minus 4. Be sure to check your answer before you submit it so that you don't enter the wrong thing or submit the wrong thing. All righty. Moving on to problem number 3. Subtract the polynomials. So we have 8ab plus 2b squared minus the quantity 2 plus AB plus B squared. So once again, nothing in front of the first set of parentheses. We can just get rid of the set of parentheses. Distributing a subtraction, we get -2 minus AB and minus B squared. Combining like terms, let's see. I'm going to put this in descending powers of B. So I've got 2B squared minus B squared is B squared. 8AB minus AB would be plus 7AB and then minus 2. So B squared, use the arrow to move it across there, plus 7AB minus, whoops, wrong thing, minus 2. Okay. And moving on to problem number 4. Same thing again, only now we have to deal with fractions. How fun is that? Fractions are fun. Fractions are your friend. Just keep saying that, and maybe you'll start to believe it. Okay, 5/6 q to the 9th minus 4/5 q to the 8th minus the quantity 1/4 q to the 9th plus 3/8 q to the 8th. Okay, so the first thing I'm going to do is get rid of the grouping symbols. So once again, I can just drop the first set. Eight, and then distributing minus 1/4 q to the 9th minus 3/8 q to the 8th. Let's see, these are like terms and those are like terms, but these first two, the common denominator of 6 and 4 is 12. So I need so many 12ths q to the 9th minus so many 12ths q to the 9th. Okay, let's change colors here. So I'm going to multiply 5/6 by 2/2 to give me 10/12 q to the 9th. 1/4 by 3/3 to give me 3/12. 10/12 q to the 9th minus 3/12 q to the 9th is 7/12 q to the 9th. All right. Now, let's see here. Putting these two together, common denominator there of 5 and 8 would be 40. So I've got minus so many 40ths q to the 8th minus so many 40ths q to the 8th. Let's go back to red. Okay, let's see. So 4/5 I'm going to multiply by 8/8 to get minus 32 q to the 8th, 32/40 q to the 8th, excuse me. And then 3/8 multiplied by 5/5 to give me minus 15 q to the 8th, minus 15/40. I keep forgetting the denominator. All right, so then we've got minus 32/40 minus 15/40, which would be minus 47/40 q to the 8th. And that should be our final answer. Okay, so let's see here. We've got a fraction. So we're going to go 7/12. And then I need to move the cursor so that it's not down underneath. Let's see, q to the 9th power. Move the cursor over. Minus another fraction, 47/40. Again, move the cursor. Q to the 8th power. Let's see, have I written up there what I want? I believe so. All righty. Let's take a look at problem number 5. Okay, so number 5. Express using positive exponents and simplify if possible. 3 to the -1 power minus 3 to the 0 power. 3 to the -1 power would be 1 over 3 to the +1, or just 1/3. 3 to the 0 power is 1. So basically we have 1/3 minus 1. The common denominator there would be 3. So 1/3 stays 1/3. And 1 we'd multiply by 3/3 to get negative or minus 3/3. 1/3 minus 3/3 is -2/3. So here we go. -2/3. Okay. Number 6, simplify the expression. We have a quantity, a base that is not 0. Well, that is 1/3 to the 0 power. So this is just the number 1. Okay. Number 7, express using positive exponents and simplify if possible. -5 to the -1 power. It's important to realize that the parentheses goes around the whole thing. So the whole -5 is the base, not just the 5. So this would be 1 over -5 to the 1 power, which is 1 over -5, which is -1/5. We don't want to leave a negative sign in the denominator. So we either want to write it connected to the numerator or out in front of the whole thing. I'm going to go with this one. Okay. So, and the way I write it, probably you won't even be able to tell. It's the same either way. Okay, there we go. All right. Number 8. Simplify the expression. Do not use negative exponents in the answer. 9 y to the -6 power times y to the 3rd power. Well, multiplying 2 powers with the same base, you add the exponents. -6 plus 3 is -3. But now I need to rewrite y to the -3 power as 1 over y to the 3rd power. So I end up with 9 over y cubed. So 9 divided by y cubed. Uh-oh, now that's weird. How it showed up there. It said it was right, but it doesn't look right. So I'm not sure what happened there, but anyway, it should have looked like that. Strange things happen on Zoom. All right. Number 9, simplify. Do not write negative exponents in the answer. Assume that no variables are 0. 3 w to the -8th power, x to the 5th, the whole thing to the 4th power. So we have a product raised to an outside power. So we attach that outside power to each factor of the product inside. 3 to the 4th power, 3 times 3 times 3 times 3, 81. Here we have a power raised to a power, so we multiply the exponents, and here as well. But we've still got a negative exponent. So this becomes 81x to the 20th power, all divided by w to the positive 32 power. So let's see here. How are we going to do this? We'll go 8x to the 20th power over w to the 32nd power. Okay. What did I do wrong? Oh, I put in an 8 instead of an 81. Shame on me. I told you to double check your work before you submitted it. I didn't do that. So right here, this should have been 81 instead of 8. Oh, well, I guess I won't be getting 100% on this test. Okay. If I just listen to my own advice. All right, simplify the expression. A squared b to the negative 1 over 5a cubed b to the negative 2, the whole thing cubed. All right, so let's condense what's inside. Order of operations, start inside a grouping symbol. Okay, let's see here. We've got a 5 on the bottom. A squared over a cubed would be a to the 2 minus 3, or a to the negative 1 power. B to the negative 1 divided by b to the negative 2 is b to the negative 1 minus negative 2, which is b to the negative 1 plus 2, which is b to the 1. Okay. Going on, I could now write that as b over 5a to the 1, or just 5a. And then finally, well, not finally, I've got b cubed over 5 cubed a cubed, which is b cubed over 125 a cubed. Well, after that last typing mistake, I'm going to double check this really well here. Got it correct, typed correctly. Let's see, that should be an A on the bottom. Okay, there. Cubed, cubed, cubed. Well, here's hoping. Okay. So I need a fraction. I'm going to have b cubed on top, on the bottom, 125 a cubed. Let's see, b cubed, a cubed. Here's hoping. Yay. All right. Okay. I know I get weird when I'm all by myself here. There's no one here to talk to. Okay. Number 11. Simplify the expression if possible. If the expression cannot be simplified, enter the given expression. So I've got p to the 7th over q to the 11th, excuse me, p to the 7th times q to the 11th over p to the 4th, q to the 3rd. Well, p to the 7th divided by p to the 4th is p to the 7 minus 4, or p cubed. Q to the 11th over q to the 3rd is q to the 11 minus 3, or q to the 8th power. Okay. So p cubed, and then q to the 8th power. Ready? Number 12 coming up. Multiply 5/3 t squared times the quantity t to the 6th plus 3t squared. So we're going to distribute. We'll get 5/3 t squared times t to the 6th plus 5/3 t squared times 3t squared. Simplifying the first product, we get 5/3 t to the 8th. And then the second product, the 3's will reduce down, plus 5t to the 4th. Now, this term, I could write it 5/3 t to the 8th, or I could write it 5t to the 8th over 3. Either way, okay. I think I'll go with that first one. So let's see here. We've got a fraction, so 5/3, and I've got to click on it to move the cursor back to the middle there, and then t raised to the 8th power, and then plus 5t to the 4th power. Let's see here. 3t to the 8th plus 5t to the 4th. Okay. Number 13 coming up. Multiply x minus 4 times 5x plus 2. So we're going to take x times 5x, which is 5x squared, x times 2, which is 2x, minus 4 times 5x, which is minus 20x, and minus 4 times 2, which is minus 8. Then combining like terms, 5x squared minus 18x minus 8. So 5x squared minus 18x minus 8. Okay. Number 14 coming up. Multiply, simplify your answer completely. T squared minus 3 times t squared minus 8. So that would be t to the 4th power minus 8t squared minus 3t squared plus 24. Combining like terms, t to the 4th minus 11t squared plus 24. Okay. T to the 4th power minus 11t squared plus 24. Okay. Number 15. 9b to the 5th minus 5t, the whole thing squared. This is not equal to 9b to the 5th squared minus 5t squared. That's a common mistake. It's 9b to the 5th minus 5t times 9b to the 5th minus 5t. Okay, we've got two factors of the base. Okay, so we get 81b to the 10th minus 45b to the 5th t minus 45b to the 5th t plus 25t squared. Combining like terms, 81b to the 10th minus 90b b to the 5th t plus 25 t squared. There's that 81 again that I missed before. Let's make sure I don't get that one wrong this time. 81 b to the 10th minus 90 b to the 5th, and then bring it back down there, t plus 25 t squared. Okay, let's see. 81 b to the 10th minus 90 b to the 5th t plus 25 t squared. Okay. Number 16, expand the binomial. Simplify your answer completely. You've got x plus 5 cubed. So that's x plus 5 times x plus 5 times x plus 5. We'll FOIL together the first two first. So we get x squared plus 5x plus 5x plus 25. All of that times x plus 5. But I can combine like terms in that first product situation before I go on. Okay, so the first two together give me this. And then I'm going to distribute here. Let's see. I'm going to have x squared times x, which is x cubed. X squared times 5, which is 5x squared. 10x times x, which is plus 10x squared. 10x times 5, which is plus 50x. 25 times x, which is 25x. 25 times 5, which is 125. Combining like terms, x cubed plus 15x squared plus 75x plus 125. Okay. So x cubed plus 15x squared plus 75x plus 125. Let's see. X cubed plus 15x squared plus 75x plus 125. Okay. Number 17, write 9.1 times 10 to the negative 6 power in standard notation. Okay, so because the exponent is a negative 6, we're going to move the decimal point 6 places, but to the left. So let's put a bunch of zeros there. 1, 2, 3, 4, 5, 6. Wow, I counted that correctly. So 0.00000091. 1, 2, 3, 4, 5, 6. Okay. So 0.1234591. I got the right number of zeros there. I believe I do. Okay. '18, write the number 1,900,000 in scientific notation. That would be 1.9 times 10 to the, let's see here, 1, 2, 3, 4, 5, 6th power. So 1.9 times 10 to the 6th power. Okay. Number 19 coming up, divide 7a squared minus 21b to the 2nd all over 63ab. When dividing a polynomial by a monomial, we are to take each term in the numerator and divide it by the denominator. A lot of you missed this question on the test because you didn't split it up. You just reduced this expression, which I'm not sure where you got that idea because I didn't teach it to you that way. All right, let's see here. 7 over 63 is 1 over 9. A squared over a is a on top, so I've got 1a over 9b minus, let's see, 21 divided by 7 is 3. 63 divided by 7 is 9. Oh, that'll reduce even further down to 1 over 3. B squared over b is b, so I got to be careful. What do I got? I got a b on top and a 3a on the bottom. Let's see here. That's going to be a 9. A there, B there, B there. Okay. All right. Let's see here. We need a fraction. So we've got A. Also, again, don't change cases. If it's a lowercase a, don't use a capital A. It's not the same. This is 9b. And then minus another fraction, b divided by 3a. Okay. And finally, number 20. A polynomial divided by a polynomial. Okay. Well, let's see. The divisor, that which goes outside, is going to be 3x plus 1. The dividend is not in descending powers, so we'll rearrange it so that it is in descending powers. There aren't any missing powers from the dividend, so I don't need to put any zeros to create columns. So I'm going to take the leading term inside divided by the leading term outside. 9x squared divided by 3x, which is 3x, which goes there. I take that 3x times the divisor, 3x plus 1, which is 9x squared plus 3x, 9x squared plus 3x. I'm going to change that, or I'm going to subtract that from what's up above. I'm going to change it to addition of the opposite. 9x squared plus negative 9x squared is 0. 6x plus negative 3x is 3x. Bring down the next term. Start over. 3x divided by 3x is 1. So I put plus 1 there. And then I take 1 times 3x plus 1, which is 3x plus 1. Put that there. Subtract that from what's up above, change it to addition of the opposite, and I get 0. So to check my work, the quotient times the divisor should equal the dividend. Let's see, 3x plus 1 times 3x plus 1 is 9x squared plus 3x plus 3x plus 1, combining like terms. 9x squared plus 6x plus 1, check. All right, so in our answer, 3x plus 1. All righty, well, I'm going to lose sleep over that one that I missed there, where I didn't listen to my own advice, and I should have put in an 81. So again, be careful not to do what I did. Well, that's it for the review. So again, just a reminder, your final is due you can take it any time from now till Monday night at 11:59 p.m. But once you open it up, you have to finish it. And once I have your grades calculated, I will email everybody and not before then. Okay. Have a great rest of the day and a great weekend. And with that, I'll stop the recording.